right. Audio's great. Good morning, everybody. Woo! We're getting started. I'm happy we're not the first session this year. I know last year we were the very first session and we had standing room only, so I'm happy that we have plenty of space. There's a lot of heckling room right up here in the front for folks to move up. Feel free to, it makes it so you don't have to go hunt for a mic. There's something I wanted to say. We're very pleased to have our new CEO and president, Tripti Sinha, join us. I didn't put it in the program. We weren't sure it was going to work out with her schedule, but I'm very excited to have her join us. She's been with us less than 2 months. She started October 15th, and we're not even to December 15th. So I'm very happy to have her. For those of you that haven't read her bio, she came to us as the CTO from the University of Maryland, and she also led the Max Gigapop for quite a few years. You can read the rest of her bio. I want to give all the time I can to her and her remarks to this crowd. So, Tripti, can I welcome you up?
Thank you, James. And good morning, everyone, and welcome to the Internet2's Technology Exchange. It is my pleasure to speak to all of you. James asked me to say a few words about my thoughts on advanced networking. So let me start with, 30 years ago. 30 years ago, Internet2, great minds within the community came together and created Internet2. And the purpose was to enable research and education. And you typically build infrastructures and services around prevailing times. And at the time, we needed a national backbone. We collaborated with other communities like the Wrens and so forth to bring advanced networking to our community. So fast forward to modern times and prevailing times, I can't give a talk without mentioning artificial intelligence. You have to look at what's pushing on this ecosystem right now. And it goes without saying that AI is front and center. I personally believe there's a little bit of hype associated with it, but it will eventually settle down and find its sweet spot. So what do we do as a community? We have to look at our infrastructure and build for prevailing times, build advanced networking to accommodate what's happened in the ecosystem. And clearly, as you know, data has taken a life of its own, and it needs to be transported. Hence, we went from 10 to 100 to 400 to whatever is next, 800. But in the end, that's not enough. As you know, it's all about what's riding on top of it. So, as you probably heard if you attended my annual meeting update, Internet2 has partnered with industry and built quite the cutting-edge network in support of and optimized for artificial intelligence. So I see that that is a path we will take going into the future, but also not just building networks for AI, but also how do we use AI as a tool to help us do our jobs better. Internet2 team, James's team is doing quite some remarkable work, so continue to follow that. And as I said in my earlier session, what is the single biggest strength of the internet community? It is the community. Right, it's the coming together of such smart individuals. The brain trust here is amazing. So I encourage each of you to collaborate, work with the Internet2 team, work with each other, and come up with solutions that work for our community to enable science and discovery and research and education. And so go forth and do some good work. So thank you for listening. These are my very brief remarks. And James, I turn it back to you now.
I know we got a microphone added to the room, and we were blessed with a few more minutes of Tripti's time. I'd welcome anybody to ask questions of her. I know she's going to be at a reception this afternoon, the welcome reception. But feel free to ask some questions. Don't feel obligated. Otherwise, I guess you can make plenty of time for your next session.
I think people want to move on with your session. Yeah. So seriously, please come to the session this afternoon. I'd love to talk to all of you informally, organically in the reception, and thank you for the invitation to speak.
Thank you so much. All right. So a quick question. This is the advanced networking track. How many of you submitted a session and are presenting at some point during this week? Raise a hand. All right. That's the advanced networking track. Raise your hand if you're presenting at a different track. All right. I like to see some folks that are looking at the other tracks as well. So this session here is not about you. I'm sorry. This is my opportunity to highlight some of the network services team. And so I want to applaud everybody that's got a session in the network services track or the advanced networking track. Please, come on. Because the program, if you've looked at the agenda, is amazing. I mean, there's a lot of wonderful talks, and I don't have time to highlight all of the ones from the community. So I have a few minutes at this time to be able to go over and highlight the impact that the network services team has had through the week. Did any of you get to go to the tutorials or workshops yesterday? All right. So this is in the past, but I wanted to highlight some of the great sessions here, not so that you can remorse what you missed out on, but so you can find these names, find these folks, and get the content if you couldn't be in two places at the same time. So they've got all the material. Please note their names, go back to the program, flag it, and be sure to fill in those gaps. I think there was an amazing set of tutorials. Unfortunately, I was only able to poke my head into a couple of them. So today, you're here in this ballroom where you're going to be hearing a number of great talks, and I wanted to highlight just a couple that really stand out as far as having an impact on some of the things that Tripty just shared with us. So you're going to hear from Christopher Green and Carl Newell shortly after this session, talking about some of the great work happening with talking to the network via MCP and through our Looking Glass, and some work that we've done with our colleagues in the community. So very excited about some of the progress there. In fact, I'm moving faster to give them more time to talk so that you can have ample time to ask questions. Did anybody see this blog post in the past week? Did any of you have any questions? No? No questions? Okay. Well, then you can skip that part of the session, which we'll have Chris Wilkinson talking about a little bit more detail about that project. Unfortunately, we still can't share all the details. You heard Tripty mention aspects of this, but I'm excited that right after I stop talking, you'll get to hear Chris share some more details about this. So, woo, right? Yeah. So who did the woo? We need some more interaction from the crowd. I appreciate those. So we also today have what's next after NGI. So I'm very happy to see a team of folks presenting on some of the community engagements that we're going to have to help with our packet refresh and looking at the vendors and our strategy going forward in 26. So I encourage you to come back for that session. Obviously, all of today is great, and many of you have sessions on the program that will keep, hopefully, most of you locked into this room, and you can't escape. But let's look at Wednesday. The NS folks, I don't know how this is happening because the team's not that large, but you can see this is just the sessions that the Network Services team is contributing to in some fashion on Wednesday. Again, I don't have enough time to share much detail about these, but I do want to call out a few things. Any Dune fans in the room? Be proud, raise your hands, both hands if you're a Dune fan. All right. Okay, keep your hands up if you know who this is. All right, good, because you're a Dune fan. All right. So you're going to get to hear Carl, and I can't remember, you're with somebody else on this one, Matt Mullins, talking about some of the fantastic work. And you can even go to the repo and get this code and be excited about some of the work that's happening on this front. Does anybody care about route integrity, route security? No, but raise your hands if you don't. All right, good answer. All right. So I'm very excited. Many of you know Steve Wallace. He's talked about route security a little bit. He's been cranking out some tools, maybe with the help of some large language models. And so I'm excited. He's got a couple that he's going to share with you on Wednesday as well. And so if you missed that, then shame on you. And the really exciting thing is he's doing this in collaboration with CADA. Raise your hands if you're with CADA. Is there anybody with CADA? Oh, there you are, over here. And so we're very excited. They received a NSF grant, CC NSF grant named Root Beer, and very excited about some of the collaborations that have been associated with that, cranking out amazing tools, getting really good insight. So I had to call out this session that's later on Wednesday, and I think you're going to hear Steve Wallace share a lot more detail about that when you go into his session and not skip it. Anybody ever deployed a perf sonar node? All right. Okay. How many of you did it 20 years ago? All right. So you fundamentally know that the birthday is this year, and I'm very excited. Timing is tonight. There's a celebration during the reception. So I will tell you that Smart Fight created this slide. And any TMBG fans in the room? Come on, raise it proudly. All right, some TMBG. Did anybody else get excited when they saw TMBS? Okay, a little inside joke. So they might be giants. I got excited about seeing that. But there may be swag if you go to the party tonight, and they're going to give a talk. The development team's going to give a talk on Wednesday afternoon as well. Yeah, that would have been too triggering. That's TMBG's protected. So this is a map that Chris Wilkinson put together very recently. I'm very excited about this one. The blue dots on this map reflects the performance assurance services that have been running per sonar as part of that service for quite a few years now. I don't know exactly when the performance assurance service got first rolled out, but basically at every node, every point in the network where a connector is served, we have a perf sonar node that's been highly capable, being used to be able to measure performance, latency, throughput. The exciting thing here, the thing I want to highlight here, is every single one of those blue dots are now part of the National Research Platform. So not only are they able to do performance perf sonar, they're running ARC nodes to contribute to CADA. They're also being available to do AI classrooms. They're being able to be used part of a nationwide Kubernetes cluster. And I encourage every one of you in this room to take a look at National Research Platform and look how you can use these to do your own testing within your networks. On Thursday, we've got several other sessions. Again, probably on Thursday it's a lot lighter. And how many of you are sticking around through? Wait, who's leaving before Thursday? Oh, Derek. Oh, goodness. Okay. Only one of you. It's okay. All right. So Thursday sessions are quite good as well. And I like it because it's a diverse mix. You have to make the cloudy networking updates. I'm very excited about some of the initiatives happening on that front and the progress that's been made. The team did amazing work rolling out some new route policy features that's amazing, that became critical to help out a member organization recently. We've got some activities that some of you have been called into on the Cloud Connect Exchange that you'll get to hear about. So amazing things happening on Thursday morning. So hopefully if you're leaving early on Thursday, you can make this before you hop on your plane. And we're also proud on Thursday to share one of the more recent outages that we had and share details about the research that went into that. I think one of the things that's critical about RNE networks is the trust and the transparency in the operations, because nothing is 100% flawless all the time, but we're a community that share those types of details and learn from them. And so you'll get to hear from Chris Wilkinson highlighting an activity that happened incredibly on Tripty's second day in the office. I told her that's not a regular occurrence. It was the first time in my time here, and so it was very fortunate that we had a great team of folks, both at in network services and at the Global NOC, dive deep into resolving this. And I apologize if any of you in this room were impacted by that up in the Northeast. And finally, this is exciting. Joanne Bender's going to be talking about some of the work that she's been doing and some excitement that she's got about leveraging data within our optical systems to do some interesting sensing. And so I'm excited. I hope everybody can stick around. I think this is later on Thursday, and get to hear some of the activities here. Because what we like to see in network services is not only the network fulfilling the production RNE data movement needs, but also providing actual research data and providing opportunities for folks to learn more about our network. And so I was very excited too. She's given a talk about how she's leveraged 3D printing to do some interesting things. I got to see some of these devices in person at OFC Net last year. It was interesting to see a diverse set of services running the OFC network being deployed with a set of small devices and 3D printed cases. So it'll be fun if any of you are trying to think how you can actually do some 3D printing to have some positive impact on the network. And then only a very, very small subset of you in this room are allowed to go into this room, because if you know Adair Thaxton, she plays a great gatekeeper to whether or not you get to be participating in Net Gurus. But that's the wonderful last thing on Friday that the network services team is contributing to. So I just wanted to take a few minutes to highlight the greatness of this team, and I hope every one of you gets a chance to pull them aside. If you find yourself not able to be in two places at the same time, please grab one of them and say, hey, give me your slides. Let's set up a time to talk, get on the Slack, engage with the community. So thank you. I'm going to speed through this so that I could give a few more minutes to the teams following me. So hopefully there's nobody out in the hallway wanting to join at 9 o'clock for the next session, because the content in these other two, and hopefully the questions, especially when we start talking about that terabit scale network, you'll have some questions. Do you have any questions for me? No questions? All right. I thought I gave somebody some money to ask one. Probably wasn't enough money. Anyway, all right. Well, with that, I'll bring up Chris Wilkinson.
Wait for our technology here. There we go. Awesome. All right, good morning, everyone. Thank you for joining us today. I'm Chris Wilkinson, Senior Director for Network Infrastructure at Internet2, and I'm excited to share an ambitious networking project that we've been undertaking over the last 9 months. As a preliminary point of order, I hope you'll forgive me. There are certain details that we've left out of this presentation. For example, who our partners are, what specific locations are being constructed into. These things are sort of constantly evolving scenario. Right now, we can't talk about those things. You can ask the questions, but we aren't going to answer. But today, instead, I wanted to focus on the technical development activity that we achieved in building this 130 terabit per second hyperscale network that's really specifically designated and designed for AI research applications. And as I mentioned a few seconds ago, we did this in about 9 months, from project inception through contracting, fiber acquisition, field work, commissioning. And there are some parts of the system that are still coming online today. For example, we've got a fiber gap in one part of the country that we're working on, but it is rapidly evolving, and by the end of December, we should be there. So over the next 20 minutes, we'll walk through how we're pushing the boundaries of optical networking technology in support of this AI research and development. Normally, James has these slides in for the sake, I'd like to just sort of provide some context about Internet2 for those who may not know. This is also being recorded. But we're a nonprofit consortium, and we provide research support, cloud solutions, and custom services tailored specifically to the R&E community. Our mission is to provide trusted, adaptable, and secure network infrastructure that empowers higher education institutions, research organizations, government entities, and cultural institutions nationwide. And everything we do is driven by community, represented here in the intersection of network, cloud, and security. And this collaborative approach is how we innovate and deliver these solutions. Sort of a sense of Internet2 by the numbers. 330 higher education members, 80,000 community anchor institutions. We reach over 100 countries through collaborative research and network connectivity, and we support 500 net plus subscribers with cloud services. We also have 50 plus industry members that partner directly with us. As a foundational element of this project, we've also recently seen our carrying capacity of our optical system double with the advent of new technologies. So the blue slide is kind of one of our official marketing slides, and I've marked it up, which I'm sure causes some cringes here and there, with some engineering numbers. So the NGI network, which is on the optical side, getting up to about 7 or 8 years old, was deployed with 800 gig wave capability. So on a metro span, we could hit 800 gigs 7 years ago with the existing technology. And that resulted in about 32 terabits of capacity per metro span. Now, that was all based on Sienna WaveLogic 5, and I'm not going to get into the marketing side of this, but those were Sienna WaveLogic 5 modules, 32 terabits per span. Now we have WaveLogic 6. Now we get 64 terabits per span. This is all within what's called the C-band, which is part of the optical spectrum that was sort of traditionally part of optical systems. Now you've also got L-band, which is a whole other part of the spectrum, and so you can build metro optical links of, say, 120 terabits per second. Now, a metro link, as we all know, has this maybe limited utility, but when you push that out to, say, 300 kilometers, suddenly you're connecting intercity. And that's kind of the basis of how this hyperscale network was built. We have this technology, WaveLogic 6, it's capable of kind of extreme capacity, and we've got these intercity links that we are wanting to turn up. So another thing that we leveraged here from a programmatic standpoint is Internet2 already runs a nationwide network. We have 26,000 kilometers in fiber that span the US. It's all ultra low loss for the most part. There's about 75 optical nodes. There's about 275 amplification sites. And so there's an established track record for us of operating and designing networks at scale, massive scale. This is pretty big scale, which gave us the knowledge and sort of fortitude to take this forward. So in October of 2024, we were on a call that was unrelated to the network, and one of our industry members asked us about our network infrastructure. And as a result of that conversation, they approached us with an ambitious vision: partner with us, partner with a bunch of your other industry members, and we would like to do something together. And so this member is a public benefit corporation focused on AI safety and the development of reliable, controllable AI systems. And they needed this infrastructure rapidly designed and deployed in this very short time scale. And there was sort of a synergy in capabilities. Internet2 brings this decade-long experience from the community for designing and developing leading-edge research networks. Optical Packet, our industry partner, brought this deep understanding of AI operations and the requirements needed for designing these networks and adapting them to large-scale AI training workloads. Together, the thought was we could accomplish something that is difficult to do alone and certainly not on this time scale. So the design requirements were clear: ultra-low latency, ultra-high bandwidth, geographically dispersed locations, and that's exactly what we did. So the result is this mission-dedicated network operating independently from Internet2's national research and education backbone that was specifically designed for this language model training application. So what was the baseline specification? So these were finalized in March. There were some initial discussions in October of 24, but those kind of simmered out. But we got to March and we had our specs. 3 network segments, 5 data centers. And I think most folks are aware there's a large boom right now in data center construction for AI applications. It's a hotly contested topic, but these things are occurring all over the country, not at the usual centers of typical telecommunications, where telecommunication channels tended to come together. They're all over the place. So these 5 data centers were distributed all over the US, and the target was 52 terabits per second of capacity. And so that was the initial approximation based on the application. And then additionally, we were designing to provide spectral headroom on all segments, giving us the ability to scale up for additional capacity. So this simplified diagram right here shows 3 segments, the 3 segments actually, anonymized of course. The longest span, about 1,000 kilometers. Other 2 spans, about 500 kilometers. And these, again, are not metro connectivity. We're talking about long-haul applications that these high-capacity links need to traverse. So the first segment came online, and what we actually saw, which is normal, is we ran the models. They're fairly conservative, and we exceeded those expectations. So on one of our segments, we achieved about 57.6 terabits per second on a single fiber pair. So this is one fiber pair equipped with a Sienna RLS line system with C-band and L-band. And I've got another slide that kind of shows the spectral density that we utilized here that is effectively fully filled. Raman amplification, very clean, very optimized. And so this was just sort of the first thing, the first target that we hit. And it's also still scalable. You can add fiber pairs, you can add additional transponders, and you can keep building out. So this 57.6 is really just that baseline. So we're really trying to not solve for today's problems, but also tomorrow's. So here's kind of the technical readout of what actually is on this single fiber pair. And I kind of wanted to just drive this down a little bit. We're at about 500 kilometers, and we're effectively delivering 1.4 terabits per second per wavelength across 48 waves. So you can see these lower diagrams. These are actually our C-band and L-band views as shown by the system. And each one of those colors is one of these carriers that is connecting these two locations. And there's no room at all within these spectral views. So there's no zoom out here. This is the total carrying capacity of the fiber and the total carrying capacity of C-band and L-band for the transponder systems. So these 48 waves are delivering 168 400 gig Ethernet interfaces. So in theory, if you actually combine all of this, it exceeds 57 terabits. It's actually closer to 67.2, but due to some software limitations and a few other things, we can't bond those. We need to upgrade the software. We can bond them, and then we can actually provide something closer to 67.2 terabits on this particular segment. So if you just think about the mental headroom on this, two pairs of fibers equipped this way, you're north of 120 terabits at 500 kilometers. That's pretty cool. I've certainly never seen anything like this. Maybe in the submarine business, you build a fiber and you fill it, but terrestrially, this is certainly the first application that any of myself or my team have worked on where we had full spectral fill and the system performed very, very well. So, just kind of bringing this all together. I don't have my timer running, so I don't actually know how long I've been talking. Kind of on a recap, Internet2 industry member, built this network for AI research, currently running at 57 terabits, certainly can scale up, full spectral pair. It's really cool. So, but we're not done. This is just one segment. So if we go back to our previous diagram, we're actually working similar capacity levels on these other segments that you see here. And so one of those is the only thing stopping it from commissioning currently is there's an air gap. There's a misplaced jumper cable or a dirty fiber somewhere in a pop, and we've been doing three-way meets trying to get together to get that thing cleaned. But if it weren't for that, I would actually have two segments to report on today. But our goal is to get all three of these segments up by the end of December. Really, December 15th is our goal, but we're getting a little close on that one. So yeah, the whole system, when it's designed, will have this 130 terabit capacity. The gear's in place. We're just finishing our final provisioning right now. And why does this matter? It's a cool project. This is scalable. It can be expanded through a nationwide footprint. It can be repeated and sort of used as a cookie cutter. These are very simple systems. One of the slides I didn't have time to make was just the basic building blocks. This is an RLS line system. There's wave servers, and then you've got your providers on either side. It's exceedingly simple. A little challenging to provision, but once it's in operation, the building blocks are basic. I got that question right before I walked up. Are these appliances? Are they how difficult it is? It isn't. It's very simple. So as AI research becomes more central to the universities and our research institutions, these infrastructure requirements are just going to continue to grow exponentially. And this networking expertise that we're developing, building systems like this, positions both our organization and the community to support future member institution initiatives in AI research. So we really feel like this is an opportunity to learn together for this particular application. In general, this is about building the next iteration, the next foundation for research infrastructure. The techniques we pioneered and the lessons we've learned, the performance we've achieved, all this transfers out. This is how Internet2 and its community works. We tackle these hard problems, push the boundaries, and then hopefully everyone benefits from what we've learned. So thank you for your attention today. It's been an exciting project, and I'm proud of what our team and our industry partners have accomplished here. And we'll hopefully have more details that we can share on this in the coming months. So thank you very much. Happy to take questions. Yep. Ooh, a question.
Just me? Okay. How many watts per bit or bits per watt?
I don't know that number off the top of my head, but I can definitely send it to you. Yeah.
Okay.
Yeah, apologies. I should have a slide on that. That's a good one. I will say these are very efficient systems in general. The compute on each end, that's where you get, that's where you're getting your watts per bit.
Hi.
Hi.
So I'm trying to picture all the tangible things that come out of projects like these in the future, and with AI, possibilities are limitless. But as you've been going through this project, have you thought about any implications for the future you could see coming out of having a network like this, or perhaps just being able to turn the dial up on our capacity to do research on AI?
Well, I do think that these projects help us build high efficiency platforms. We have seen folks that are interested in combining resources, for example, and stacking more and more bandwidth onto a single fiber. We've seen our compute centers within the community, like TAC and the facilities, for example, in Ohio, that are interested in interconnecting at extremely high speeds through various networks. And so maybe the R&E community won't exactly need 67 terabits tomorrow, but I do think we're ramping up towards needing to
They will.
put very high, I meant tomorrow, not next week. I agree with you. But I think being able to understand how to build these very high capacity systems and combine these multiple use cases is going to benefit us in general.
100%. Thank you.
Sure.
Hey, Chris.
Hi, Julio.
So in your talk, you referred to the hyperscalers and AI research. So how would an AI researcher reach out to Internet2 to be able to utilize what you've built?
That's a great question. So we would recommend that they make a point of contact through either our community engagement folks or through myself or Christian Todorov, who is the other primary flywheel on this project. And then we would see what connectivity. There is actually a broad interest in using Internet2's position and our connectivity with these partners to facilitate exactly that type of activity. And we don't need to be in the middle, but we would be happy to connect the dots, if you will, and the people that are in, for example, these industry members and in our community together. So I don't know that that was a specific answer, but that's the one I think
good.
of. Yeah.
What do you foresee, or the possibilities of? Because I think your focus was mostly on a national footprint. What about taking this international?
So there is some interest. We've had some follow-on discussions about building similar systems. for specific applications, both within the community and also within industry. So I think we will see this topology grow. It may be for a different set of partners, it may be for a different application, it may be from an application inside the community. But I think these mission built, there's sort of the traditional backbone infrastructure, which we will continue to invest in. As Matt Mullins will speak, we're designing the next generation network, right, for Internet2. We have not developed an acronym. We're taking suggestions. But that'll be sort of 1.6 terabits per second minimum, but probably more likely higher than 2 to 3, much lower than 67. But we're going to continue building that core backbone, and then also these sort of mission-built networks to support specific applications. So I do think we'll start to see these either at this scale or at smaller scale coming up as, and Internet2 is very interested in partnering with the community to build these types of systems as they're needed. And I think that's one thing you and I have worked fair amount with in the recent years. There was a time where the Internet2 network was a very fixed entity, and it was difficult to get changes made to the network. At least in my tenure, we've really pushed past that, and now I think we've made somewhere between 20 and 30 topology modifications, and we've brought specific capacity online to meet specific demands, and so we're in a much more flexible space for meeting specific applications, but also thinking big.
Stephen from Link, Oregon. Can you share some information about these, like the wavelength characteristics, such as spectrum width or baud rate? Hopefully that's not proprietary.
It's not proprietary, so they're all that data is, we're really just running the standard WaveLogic 6 configurations. So I'm trying to remember, I don't think I've got that slide. I'll have to follow up with you on it. I've got that data, it's just not in my deck, and I don't remember it off the top of my head.
Thank you.
Yeah, of course. I'll follow up with you, Stephen. One last question? I'm getting I got the, but I'm asking. Anyone last question? All right, thank you all, appreciate it.
I don't know, can you hear me? There we go. Like Chris, we have something on the more cutting edge and new side of things to share. AI and a network of consoles. So Carl and I would like to tell you about this experiment that's been in the works for the past several months. We're going to look at a new idea where cross-domain troubleshooting is paired with an open source console that has AI integration. So many ideas put together in one. So what is a console? When we say that, we mean a console is a web-based admin tool which enables its users to visualize, troubleshoot, and in advanced cases, even manage the network resources that go underneath it. Network resources can be many things. We think of nodes or devices, services that run on those, organizations, anything that is a part of the network or that comprises the network. Several years ago at Internet2, we began the development of a console that was intended to enable the community to manage Internet2 network services and resources. Today, we call it Insight Console, and we have a whole booth dedicated to it. You can go out those doors and to your left and talk to me about Insight Console or this idea as well. And it can be accessed at console.internet2.edu. And a large part of Insight Console is available completely unauthenticated. A big part of it is public. The Looking Glass, a useful tool many of you use for troubleshooting. Some regional networks, some of you have also developed your own consoles or portals, it's another term we often hear, to meet needs similar to the ones we have at Internet2. And some regional networks, some of us have no console at all. In 2025, this year, we started asking the question, what does the next console look like? What comes after Insight Console? We started asking, what if? What if the next console is open source? What if you could run your own instance of that console in your own domain, connected to your own network resources? It doesn't have to be the only console you run. Maybe you already have something like it, already have a portal, and this console could be supplemental to that. Or maybe you don't have a console at all, and this next console is able to fill that gap for you. And it's open source, so you can contribute back, and your improvements will benefit everyone else that uses it in the community. Imagine this next open source console. Imagine it enabling you to potentially your tenants too, being able to manage, visualize, and troubleshoot your network resources, kind of like Internet2 Insight Console does for Internet2. And in your mind's eye, picture this. Picture this open source and this open source console and the unique thing that it can do, which is, we're going to call it cross-domain resource sharing. We made that up. Maybe there's a better term for this. So your network is made up of resources, metadata, troubleshooting information. Imagine being able to share that troubleshooting information about your network into the console of one of your peers in the community. Or imagine that you are the one troubleshooting a network service that spans your network, the Internet2 network, the network of a community member far away. This happens. We have networks that go all the way from an industry member across Internet2 to a community member. Happens all the time. And all the information that you need for troubleshooting that across many domains is available to you in your console. And imagine that it's safe to share information in this way because each community member's console controls access to the resources, metadata, and troubleshooting information in your console's domain. So you can only give up the troubleshooting information that you specifically authorize to people who are specifically authorized. There will certainly be cases where you may want to remain private and not connect your console to other consoles at all. And the console could still serve as a useful tool for visualization, troubleshooting, and management for your network. Now, if many of us did this, if many of us connected our consoles together for the purpose of extending metadata into and troubleshooting into each other's consoles, we would have a federation. We could call it the Trusted Infrastructure Federation. Again, we made that up. I'll say TIF for short in the future. That stands for Trusted Infrastructure Federation. A federation like this unlocks interesting workflows for cross-domain troubleshooting, especially when assisted by AI and large language models. And I'd like to invite my colleague, Carl, to share more about that.
All right, thanks, Christopher. Who here knows what the Insight Console Looking Glass is? I'm going to pretend I'm James. All right. Who here uses it? On a daily basis. All right. Who here finds it difficult to use sometimes because you have to type in network commands? Yeah. All right. Who would run the looking, if we provided the Looking Glass console, who would run it, who would want to run it on their network or parts of Looking Glass? Awesome. You can do that right now. And that's kind of what we're talking about. So we've already taken the Looking Glass pieces of the NS API and extracted them and packaged them up. And folks can go grab that right now. It's in a GitLab repo. I don't think we have it in the slide deck, but we can share that more broadly. You can go get at least the Looking Glass API pieces and deploy them right now on your network. And so I'm going to talk about two of our members that we partnered with to try an experiment here. First, we've been working with UEN and Daniel right here. Daniel, raise your hand. Embarrassed Daniel. To get a Looking Glass deployed on the UEN network. That went up 3 weeks ago, right? Yeah, I was at AutoCon, and Daniel messaged me saying, hey, we're ready to go. We have some questions. So I hopped on a call with Daniel, Troy Jessup, who's their CISO, and a few other folks. Apologies, I don't recall their names. Had a discussion. They asked all the hard questions, because they were deploying this into production on their production network. And this was the first time that any pieces of their production network, the configuration and operation was exposed, not broadly to the internet, exposed directly to us. But they asked a lot of great questions, and luckily I gave all the right answers. So Troy approved it, and we got it deployed. We've also been working with Ocean. John, raise your hand. To get that running at Ocean as well. Unfortunately, just due to timing, we didn't get it done in time for this. He's got it running today. So just in time deployment. So unfortunately, I won't be able to show anything with that yet. I mean, we could go live and update the chatbot, but I don't think we're going to do that. And so again, what we want to get to, at least in this pilot that we've been working on, is can we deploy a Looking Glass on multiple organizations, and can we ask interesting questions? And so that's one of them. Can you test the latency between two of our members? Right now, and I'll get to the architecture of what we have deployed later. But we're using Claude currently as our LLM, and I'll talk about some future we want to do with that. So let me get this running. All right. All right, so again, what happens right now is there is a Looking Glass container running on the Internet2, against the Internet2 network. It can run various curated operational commands that are against our network. There was one running at UEN as well, and we have a chatbot that we wrote, and this is what Hawat is, and we've talked about this before, and we'll talk about it again tomorrow. But what we did is we just updated the chatbot to know that there are two Looking Glasses out there, and now, can we ask interesting questions about these? So, what devices are available from UEN and Internet2? And this is all, pre-recorded, mostly because doing live demos with this is kind of difficult. Mostly, you have to wait, 10, 20 seconds for a command to execute and run. So I'm just it's just scrolling through, and we updated it so it could show each of the tools that are being called. First, it pulls down the API spec, and then it knows, I can look for devices. It grabs the devices. You can see that in the device's endpoint. And, I did it. I clicked the wrong thing, Christopher. I knew I would. This is difficult. But there you go. It queried the UEN Looking Glass, pulled these devices. It makes some inference about what those devices are, and they have 6 online. And then we get into the Internet2 devices, which we have 94 devices online. And this is always interesting. It took that data and it aggregated it for us. I didn't ask it to do anything like that. It's just it's kind of the sometimes helpfulness of LLMs. We have aggregation and core routers and global exchange points. And it sort of talks about what kind of networks we have, for research and education. So moving on. Just show me the neighbors. So now I'm asking, it doesn't know anything. I'm just asking, essentially, is UEN and Internet2 connected? And again, I'm letting the LLM sort of decide what commands to run in our looking glasses to figure out if there's any connectivity. And here, eventually, it's going to run LLDP. You couldn't actually see that in the expansion. But yeah, it ran LLDP on these routers and starts to figure out, which of the UEN interfaces, it tries to infer that, are connected to Internet2. And moving on, let's see. Sometimes it gives some interesting information on connectivity. Well, we have good connectivity. Oh, I did it again. Now let's find our spot. Oh, here we go. And this is always a fun one. Draw me an ASCII diagram of the network. I'll just skip ahead to that. It knows all the information based on LLDP, and if it did it right, it didn't actually go and requery that. It just used the history of this. But yeah, so this is it attempting to draw a diagram of your network. And think about it: if you take this and maybe you have another MCP server that generates mermaid diagrams, you can pipe this data to something else, and you can start generating these network diagrams by just chatting with the LLM. All right, I'm getting the signal. 2 minutes. I do want to get to the last slide. Okay, we have extensive connectivity. What was my last query? Oh, determine which Internet2 interface is connected to UEN. What routes is Internet2 receiving? So these are queries I really want to get into. Like, I'm trying to troubleshoot routing on my network. Can I ask questions about, are you receiving my routes? And it goes and runs a bunch of, figures out the interfaces, runs some show BGP commands, and figures out that in this, at least if, these aren't always accurate, like just based on what it saw, this is the information it had. There's probably better ways to get the information on connectivity about the networks, like querying our database. But for now, this is just network config, knows we're connected, and then, running various show route commands, understands what ASN UEN is and what routes it's advertising the Internet to. So again, potentially moving on to, could we troubleshoot routing issues using this? I just wanted to show this slide. This is from Daniel. So again, the Internet2 side of this has a chatbot built in. The stuff that we release right now doesn't have that, but we will include that. So Daniel is just running his own LLM locally on his laptop, configured to talk to his looking glass and our looking glass. And again, don't worry about the content. It's mostly to show that the interesting thing here is like we have all these deployed, and anybody can that have access to that looking glass can run, use an LLM to chat with our networks. All right, and I guess I said I was going to talk a little bit about the architecture here. What we have currently deployed, UEN, and pretty soon Ocean, is just the looking glass backend, which was originally written as a REST API and Fast API, and which is really easy to turn into an MCP server by just adding, importing a new library and adding a couple lines. On the Internet2 side, we have the same thing, the looking glass backend, but we also have this little application that we've written with the front end and Streamlit the back end using Pydantic AI and talking to Claude. So the future, none of this is, we're not committing to any of this. This is a very future slide. We have to determine if this is a feasible project. So some things, again, Christopher talked about deploying an open source console across networks with a pluggable backend. So, right now we already have the looking glass. Internet2's virtual networks will will eventually kind of migrate into that concept. And possibly in the future, depending on some, what else is available out there and maybe what other people are working on with network automation, we could, include something like virtual networks that is deployable in consoles to our other members. And then also, whatever you want. If you want to build some kind of backend plugin just for your network, that's feasible. So we'll be working on that. Registry service is, right now it's easy for us to deal with the 3 looking glasses deployed. That's just manual config. But we sort of envision, a registry service for the consoles to, register themselves with, and a lookup service to figure out what's available out there so you can automatically configure your tools. I'd say it's probably very similar to the Persona lookup service. And lastly, a place to run LLMs. Again, we're currently using Claude, which is a commercial product, and we're paying for it, but we are also heavily engaged with NRP, the National Research Platform, again, which has lots of nodes deployed across the country. A lot of these have GPUs. They have a lot of large GPU clusters. they are running a hosted LLM service, and we are working to, figure out which of those LLMs are really good for the kind of work we're doing, which is, network troubleshooting, especially tool calling on the network. So the advantage to this is we get that work and we share that knowledge, and anybody could use these LLMs for free instead of, paying to a commercial provider. So I guess one is, a part of all of this was we called it a pilot because we didn't know where this would go. We were still sort of in the pilot stages, but is this something interesting in the community? Is this something people want to support or people would deploy on their networks? Hand raise? All right, cool. That's a good enough number of people to keep going. So with that, we'll wrap it up and open up the questions. Again, go to the Insight Console booth right outside, or if you're interested, you can go to this URL and sign up for, is it schedule a Zoom call? Or
That actually puts you in a Google form.
Google form, yep, sorry, that's what it is. Just to show your interest in TIFF Console and the pilot. Steve.
Thank you. So I'm curious, if you asked it to show the accepted versus received routes, would it figure that out?
I don't know. The biggest problem with, and we have to sort of figure this out in the back end, with any kind of show route, especially show BGP or show route, if it's querying the default table and you happen to put the global routing table default table, that data that comes back is bigger than the context window of the LLMs, so it immediately breaks the whole process. So we just started doing this. I haven't figured out the right way to solve that. If we restrict it to certain commands, but yeah, I mean, we could. I think through the right kind of prompting, or maybe there is some tool in the Looking Glass that is like the rejected routes, and that just turns into, depending on vendor specific, the right commands to figure out which ones are rejected.
Thanks.
Christopher?
Okay, good morning, everyone. My name is Simone. I'm from Deaton. I'm going to tell you a little bit about what we did with regards of network automation in the last few years. You all know each other. You don't know me, so just introducing myself. I'm Italian, like you probably already noticed by my accent. I'm a father of twins. If there are any parents of twins I would like to meet. I spent most of my professional life in a university in my hometown, Pisa, and then I moved to the Netherlands. I tried commercial ISPs, and then I got back to the research and education world, joining Deaton in 2019. This is my second TechEX, and this is the first time I present here, so bear with me. But as a bottom line, you can ask me anything. So, as I said, I work at Deaton. Deaton, it's an association of national research and education network in Europe. We run this network. This is our European footprint, and we coordinate and participate in EC-funded projects. And on top of the network, we offer a portfolio of services for research and education that goes from identity management to computing resources, etc. And we're part of the global R&E community, and that's why I'm super happy to be here. This is our intercontinental footprint. As you can see, we peer with Internet2, we peer with YesNet, and then we go down to South America, Africa, and all the rest of the world. So back to why I'm here. Network automation at Giant. So we started in 2019 playing around with stuff like SaltStack, Ansible, that we added Jenkins on top of Ansible. And yeah, I'd like to say we were playing around. But in 2023, in April, we understood that we had to retender our IP MPLS network. And this forced us to upgrade our game, and that's when we decided to adopt the workflow orchestrator, which is a workflow engine originally developed by eSurf, the Dutch ANREN, and ESNet. And we wanted to use WFO to pilot our Ansible logic. And we were going to do this through a custom component called LSO. In June 2023, we awarded the tender, and so we had to move away from our Juniper network towards a fully Nokia SROS network. That was the moment where we really committed to the fact that this migration should have happened completely automated. June 2024, the first phase of migration starts, very simple. Go on the POP, install the router, configure it, connect all the core links with the rest of the POPs, leave the Juniper node with all your users functioning as a P. So very simple initial configuration for these nodes, just a label switching router with all the core links connected to it. January 2025, we started migrating services. We started migrating users from Juniper to Nokia. And while in the first phase we were moving from the core to the edge, in the second phase we would start to go back, moving from the edge to the core. Now it's December, we still have 1.5 node to finish this migration. So here I am telling you our experience. After playing with a lot of tools, we decided that the best approach would have been top-down, and we made certain assumptions. Configuration on boxes is not there just because, but it must be there for a reason. It either belongs to the node, so it's there because the node is there, or it belongs to a service, whatever kind of abstraction you want to think about. So the whole node configuration is a composition of these joined parts that represent, as I said, either the node or the service. The other assumption, the other strong assumption that we made is that we didn't want to approach node by node. So we are not rendering the entire router configuration, pushing it and looking for diffs. We wanted to be a little bit more surgical. And the other prerequisite or assumption is that we want, when a service involves multiple routers, we want to focus on the service itself. If you think about a simple core link, you want to focus on the pipe. And the fact that it's attached to a couple of boxes, it's a consequence. So that was the set of decisions we made at the beginning. And we said, okay, let's start from the top and go down. Configuration will follow. And anyway, we were pretty tired of thinking about prefix lists, misalignment, and things like that. So we started thinking about what are routers made of. And for us, there is this layer of configuration that belongs to the node. We call it base config. And it's all about everything the node needs to be alive. So chassis configured, line cards, access management, etc. On top of that, there is a network insertion layer. So for example, even if you have core links and your router is attached to the network, you maybe need to update your IBGP mesh, you need to populate certain monitoring tools, etc., backups, stuff like that. And then on top of it, you can already deploy services, or you can have services that have dependencies. Stupidly, if you think about the VRF and you want to add a port in a VRF, the VRF must exist. But if you zoom in, you can still see a service as a composition of smaller parts. You will probably need something that is your demarcation between your domain and someone else's domain. And this could involve physical interfaces. You will need something like a VLAN, where you can actually deliver the service. And then on top of it, you can have different services that can be layer 2 or layer 3. And if you zoom even more, for example, this is a layer 3 service based on BGP, you could have like a bunch of components. So multiple BGP peering sessions with their own input and output routing policy, with a bunch of knobs that you can turn on and off. Do I want BFD? Do I need authentication? Things like that. So following this approach, this is our current portfolio. This is what GAP, so the Géant automation platform, manages for us. So we manage infrastructure-facing services like nodes, core links, routing instances, and a bunch of users-facing services, layer 2 circuits, our RNE proposition, and our commercial internet. The directly attached servers is something we are still working on. So, as I said, Workflow Orchestrator is the cornerstone of our architecture, and it gives us this orchestration layer that connects our systems, authoritative systems like IPAM, like Netbox for interfaces, but also other systems like monitoring systems, backup servers, etc., etc. It connects it together, and it orchestrates the retrieval of data from these systems to pilot southbound our LSO, which in the end will pilot Ansible. It has a graphical user interface that operators can use, and it's fully integrated in our Core AI infrastructure. We run it in a very simple setup, multiple nodes with Docker Compose, protected by Keep Alive D, super simple, all deployed obviously by Ansible. I was talking about LSO. The idea for us was to fully leverage our experience with Ansible, so we needed something that could be wrapped around Ansible and call an Ansible runner. But we didn't want to start using spaceships like AWX or Ansible Tower. So the idea for us was have something simple that exposes an API that does exactly nothing. We have it, it's available for the community. It can work standalone, or it can work in a distributed mode with runners where jobs get submitted and a runner will pick it up. And recently, we also added the possibility to launch arbitrary code so that you can get, for example, structured data instead of an Ansible playbook output. Here, some examples when you get the slides, just to see how it looks like. So this is just a different diagram to show you all the moving parts. And I really want to focus about where things are. So you see on the top the GUI, where the operator interact, the service orchestrator, so workflow orchestrator, with the workflow engine, and the service database that is responsible to keep track of your services, but also the state of your services. So managing lifecycle and managing the state of synchronization with the network. Then you have resource management on your right, where you can get data from authoritative systems, and on the bottom, the real low-level mechanics, templates that get compiled and pushed on the device. So where is design? Design is in your service database when you choose an attribute or you choose the value of an attribute. For example, if you say that a certain connection is primary or backup, you're not specifying any kind of number. You're making a design choice that will be reflected in reality looking at your Ansible inventory, and then actually a primary connection will mean local preference 150 med equal 0. Design is also in your Ansible roles, in your templates, everywhere in the low-level mechanics you are expressing design. The data comes from authoritative systems, comes from the orchestrator for instance-specific data, it comes from the Ansible inventory for generic, let's say, design data, which prefix list, which IP addresses, which numbers. And finally, where is the implementation? The implementation, again, is split in the high-level implementation. So it's the workflow engine that decides in a migration, I will go to the source router, deactivate config, then go to the destination router, push the new config, and then go back and delete the old config. And of course, in your Ansible roles, in your templates, selecting the right dialect that you should use. Clearly, a migration like this, it's something that goes beyond only automation, so it's a complex process. It starts with obviously the planning of the physicality of things. There is a phase where we parse the current configuration and we ingest the data that we care about into the orchestrator, and that's also when we do pre-checks. Then there is a maintenance window with people on site moving fibers and people from the office operating the orchestrator, and finally an aftercare session where we fix any incident and talked about the lesson learned. So this is what we did until now. In this graph, you can see the number of services for each and every site. We roughly did one site every week since February, something like that. So it has been a year. And you can see now at the end of the year, we are hitting very big routers. So from 20, 50 services, we are now hitting 180, 190 services. And when I say services, I'm actually referring to VLANs. This is the actual metric. So you could have a VLAN facing an internet exchange with hundreds of BGP peers. For this reason, we needed something a little bit more powerful, because even if migrating one single service takes 3 minutes, when you have hundreds of services to migrate, you don't have time. But as I try to say, in the orchestrator, you have the whole stitching of your components. So you know that on top of a certain port, there are multiple services existing. For example, you can have a bunch of BGP sessions, some layer 2 circuits, access to specific VRFs. So you can tell the orchestrator to spawn a parent workflow to migrate actually the fibers, and then as many child workflows as you need to move all the services. And this has been a great improvement in sense of timing. Every child workflow is independent, can fail, can be retried, can be also be aborted if needed. And the other important thing is that Moody, which is something I will talk in the next slide, will monitor it for you also in this scenario. So what is Moody? It stands for Monitoring on Demand. And the idea is actually very simple. Starting from the assumption that the orchestrator has a complete vision of the network and knows what will happen in the future, you can spin up a small telemetry stack, GNMIC, Prometheus, and Grafana, and start subscribing for subscription that do not exist yet on your destination router, but will exist at a certain point during the workflow. So in the end, what you get is this nice 1-second resolution monitoring system where you see optical levels, you see traffic levels, you see your routes that gets exchanged, almost real time. And this is used to actually validate the change. And when you're done, everything gets teared down and nothing has ever happened. Every workflow gets its own Moody instance, so we can run things in parallel. And this is me and my colleague migrating Amsterdam Internet Exchange. Yes, GAP. We don't want to use it, we don't want to keep it as a migration tool, but we really want to make it the way you interact with the network. And this is happening right now at different speed for different products. For example, for core links, these are completely under GAP. Nothing gets deployed manually. There are no exceptions. These are simple products. So we do provisioning and deprovisioning. We do migration. We do capacity management. We do IGP management. We did a lot of upgrades because we won a tender called Euro HPC, where we are supposed to interconnect European high-performance computing centers. So the red part, our western ring, is all 1.6 tera, and the yellow part, which is absolutely outdated, is all 800 gig. And all of this has been done only using GAP, so completely traceable and completely automated. There are more things that we want to add. Commercial peer lifecycle management is happening right now. ZR Plus optics also on the horizon. And again, we want to build things on top of GAP, like Moody, but also like this map. This map comes directly from the orchestrator. This is an introspection inside the orchestrator. This is a bonus slide, so might be interesting or not, but the moment we started migrating very big sites, our Ansible interactions became very, very slow with timeouts and annoying things. Digging a little bit in the code, we use Ansible Net Common collection. We figured out that in distribution Ansible, they take the whole configuration pre and post change to calculate the diffs. When you have a small configuration, this is okay. When you have hundreds of thousands of lines of configuration, this really doesn't work. But you can fix it using this RPC call called MD compare. So I'm wrapping up. 2026 for us means one more node in January, and then clean up, and more introspection, redo things that we don't like, and really invest to make GAP the only way to interact with the network. We want to move away from Docker Compose and look at Kubernetes. We want to take a little break because we deserve it. And then looking ahead, there are self-service propositions. What I saw yesterday on Inside Console was amazing. More interaction with other tools, so expanding our integration, and optical layer, LLM, everything Carl talked about. It's going to be a fantastic year, 2026. So to conclude, if we did it, you can do it too. You can look at what we did with the link. The top-down approach has been successful for us. I feel like recommending it. And don't forget that design is the only real source of truth. The rest is just knobs and numbers. The tooling doesn't really matter, but Workflow Orchestrator is really great. And you can see in this picture the people that are using it in production. Surf and YesNet, Giant is also partner. R&E people, commercial people. It's a very active community around the workflow orchestrator. So if you want to join us on Discord, this is the QR code. Thank you very much.
We have time for a question or two.
Hi.
Ciao.
Okay, the idea for Moody, I never thought about that before. That is awesome. I wanted to ask, you have an instance of Netbox, and then you have, your Ansible and Workflow Orchestrator, where you're also storing, data needed to run stuff on an inventory. Do you have any challenges nowadays or lessons learned around choosing where to keep certain pieces of data, or avoiding having to duplicate data in different systems?
I can say that we consciously duplicate because we want to have a winner. And in our philosophy, let's say the orchestrator is the winner and all the rest must obey. There are different approaches to this that are equally in production, but right now there is no evidence that one approach is better than the other one.
Awesome, thank you.
Thank you.
Thank you,
Thank you,
speaker
everyone.
once more. All right, we've got a break now until 20 after. Speakers that are coming up for the next or that are going to present in the next session, we'd appreciate if you see me or Frank Ciesink, I think, who's going to be the actual moderator. Okay, thanks.